Yes. Good morning, dear students. Let us quickly revise today paper 2 of chemistry. Okay, we will first revise unit number 2, which is inorganic chemistry. In that, there are two subunits, chemical bond and reactivity, and another one is oxidation and reduction. Right. So let us first see chemical bond and reactivity. As we know, in this unit, you have different types of bonds are there, then different theories of bondings are there. Okay. So prepare for all types of bonds very carefully. We know there are two types of bonds, primary bonds and secondary bonds. In primary bonds, you have ionic, that is electrovalent and covalent type of bond. In secondary bond, you have weak bonds like van der Waals forces and hydrogen bonds. Okay, so prepare for the definition of each kind of bond. Now, quickly, just to see compare between all types of bonds, you have different classification. As I told ki if all four bonds you want to summarize, then ionic kind of bond are formed by electrostatic force of attraction, and properties include they are hard. Ionic solids are hard, they have high melting point, usually they are soluble in polar solvents and in the solid state. Okay, ionic compounds are electrical insulators, but when we mix in solution, any solvent, okay, they become conductor. Right, so examples include a combination of s block and p block element where they have electronegativity difference greater than 3. Right, they are ionic compounds. In covalent compounds, now bonding is not via electrostatic force of attraction, it is via shared electrons. Okay, so covalent bond is formed by sharing of electron. Now for ionic compound, what we have seen, it is electrostatic attraction. So for formation of, if NaCl is one of example of ionic compound, then you know there is first formation of Na plus ion, Cl minus ion, and then these plus minus ions attract each other to form ionic bond. Whereas in covalent bond, it is not situation. Okay, the two combining atoms come closer to each other, they, in order to complete their octet, okay, they share electrons with each other. Now covalent bonds are very hard in, compounds are very hard in nature. Of course, they have high melting point, they are insoluble nearly in all the liquids. Diamond is very well known example of covalent compound, and they are semiconducting in nature. So molecular compounds may van der Waals forces of attraction, they are very weak forces of attraction. Okay, metallic bond और ionic bond में हमने comparison देखा था. In case of metallic bond, there is positive and negative charges are there. In ionic bond also positive and negative centers are there. In ionic bond, anion and cation are distinct. Cation is what? Positively charged ion. Anion is negatively charged ion. So they are some elemental anion and cation, okay, or molecular species. Whereas in metallic bond, your cation is metal ion, okay, and instead of anion, now you have electrons and they are free to move anywhere. So only difference in ionic bond and metallic bond is anions are not there in metallic bond. It is electrons which are freed from the metal cation itself. Okay, so the electrons are free to move. So metallic bond or metallic elements, they are good conductors of electricity even in solid state. You know, all metals like copper is very good conductor. So this is simply difference between the four types of bonding. And remember the strength of bond. Okay, now apart from this, we have seen different characteristic of each type of bond. Okay, so like ionic bond कैसे form होता है, and the peculiar properties of ionic compounds, how different factors affect. Okay, ionization energy रहेगा, electron affinity रहेगा या lattice energy रहेगा. Remember with the all respect. Then characteristics of ionic compound, okay, whether they are soluble, insoluble, and depending on, we have seen some traits also in the periodic table. Okay, so just go through each and every slide carefully. Then we have covalent bond. In covalent bond, we have seen two types of bonds where bond is formed between same kind of molecule, it is homonuclear, and another one is heteronuclear. In homonuclear, you have same species binded with each other, so since same element is there, there is no electronegativity difference. So this kind of covalent bond is non-polar covalent bond, right? And you have heteronuclear um, covalent bond where two different atoms are involved, and when two different atoms are there, there will be very slight or more how somehow electronegativity difference will be there. So these types of bonds are polar covalent bonds. So HCl is under polar covalent bond. Okay, HCl में you will see कि hydrogen is your uh, S block element and chlorine is P block element, which are at extremes of the position. But hydrogen ka electronegativity is not like alkali metals. Okay, hydrogen does not show any property as like alkali metal, though it is placed in first A. Okay, so NaCl, even lithium chloride, all are the ionic compounds, but only hydrogen bonded with the p block elements, it forms covalent bond. Okay, this is peculiar property of hydrogen. Though it belongs to alkali metal family, it doesn't form ionic bond with the halogens. Okay, the reason is electronegativity difference is very low, but the bond is polar covalent bond. Okay, then we have seen different properties of covalent bond also. So remember covalency of elements, like remember covalency of hydrogen is 1, oxygen is 2, nitrogen is 3, that of carbon is 4. Okay, so valency as well as covalency. Coordinate bond भी हमने देखा. Coordinate bond is formed by sharing of electron pair, right, from one atom which is called as donor atom to the another atom which is called as acceptor atom, where donor atom must have lone pair of electron to share and acceptor atom must have some empty orbital in it to accept that electron pair. So since it is sharing of electron pair from one atom to another atom, they are always shown by arrow. Okay, arrow is pointing towards acceptor atom and it starts from donor atom. Okay, then conditions you just go through. Metallic bond also you just go through. Then hydrogen bonding में हमने देखा था what is hydrogen bond. Remember the examples of species which show hydrogen bonding. Okay, and the phenomenon like HF is example, H2O water molecule, ammonia is some of examples of the molecules which show hydrogen bonding. Okay, then let us move towards characteristics of ionic bond. Covalent character of ionic bond, wherein we have seen two important concepts: polarization of ion and polarizability. Okay, what is polarizing power? It is extent of distortion, or polarization depends on power of cation. Okay, polarization is power of cation. Polarizability क्या है? It is susceptibility or tendency of anion. Polarizability is with anion, polarizing power is that of cation. So polarizability is susceptibility or tendency of anion to distortion. Okay, तो polarization less है, मतलब bond is ionic bond, polarization is more, then bond is having more covalent character. Okay, so uh, you have ideal ionic bond where it is formed by electrostatic force of attraction. Okay, with decreasing cation size. Okay, cation size small हो गया तो you will find कि it is polarized, little polarized species. Okay, with further decrease you will find there is more polarization. So increasing polarization of anion by the cation. Okay, so what are the extent of polarization is measure of tendency of system to attain covalent character. So polarization is basically when any bond undergoes polarization, it is moving towards the covalent character. And if you have dipoles separate, okay, dipoles plus and minus poles separate, that will be ionic character. Okay, so different factors we have seen. Size of cation, remember all the trends. Okay, smaller the size of cation, greater the size of anion, greater is extent of polarization. Okay, तो polarizing power किसका होता है, cation का, to polarize anion. Okay, increases with decrease in its size. cation का size decrease हुआ तो polarizability also changes. So remember all the trains. Examples may be on either trains or some example will be given for comparison. Okay, so remember these trains. Even the charge, with respect to charge, what happens is with the cation and anion इलेक्ट्रॉनिक कॉन्फ़िगरेशन हमने देखा था, उस पे भी क्या इफेक्ट हो रहा है. ओके, लाइक कि डी ऑर्बिटल इन्वॉल्व हो रहा है कि लाइक 18 इलेक्ट्रॉन और 8 इलेक्ट्रॉन, टू कॉन्फ़िगरेशंस वी हैव सीन. तो 18 इलेक्ट्रॉन वाले कैटायन में क्या हो जाएगा, पर्टिकुलरली ट्रांजिशन एलिमेंट, एंड 8 इलेक्ट्रॉन कैटायंस आर योर अल्कली एंड अल्कलाइन अर्थ. तो उनमें क्या हो जाएगा, तो दैट इज सिंपली डिफरेंस. तो all are summarized here. Covalent bonding is favored by small cation size, large anion size, large charges on either cation or anion, or if cation is having 18 electrons in the outer shell, will be more preferable for formation of covalent bonding. Okay, so I hope this nature of bond is very clear to you all. Now let us quickly see what is Levy's electron dot structure. Okay, so based on outermost electronic configuration of your molecule, so pictorial representation of bonding in molecule uh, with respect to how electrons are arranged. Okay, that is called as Levy's electron dot structure. So for that we have seen different steps and what can be done, do's and don'ts for Levy's electron dot structure. So just go through this how the electron dot structure can be derived. Okay, so we have seen many molecules for that. Just go through all the molecules. Okay, all the steps are summarized here, and limitations of electron dot structure, Levy's electron dot structure, are explained over here. Okay, so we this structure fails to explain geometries of molecule, then the quantitative aspect of chemical bond. Okay, how much is covalent character, how much is ionic character, it fails to explain. Okay, many properties it fails to explain, like कि we know कि octet complete होता है molecule का, तो it is very stable, but we know BF3 में only 6 electrons are there. Then too BF3 is very much stable molecule. Even PCl5, in this molecule 10 electrons are there in outermost cell. Then too this molecule is very much stable. SF6, 12 electrons are there. It is having 4 electrons more than the octet. Okay, then too this molecule is highly stable. So your Levy's electron dot structure fails to explain such a type of molecules which contain either more than or less than 8 electrons in their outermost state. Okay, even the geometry is not explained by electron dot structure. So many attempts were done, like Sedgwick-Powell theory has come out, which depends on the electronic configuration of their central atom. Okay, so you have three basic theories: Levy's theory, Sedgwick-Powell theory, and the VSEPRT theory. Okay, so remember the basic principles of the all these three theory. In Sedgwick-Powell theory, geometry of molecule depends upon arrangement of orbital around the central atom. Okay, and the angle they make with one another in space around the central atom. So this theory basically deals with the arrangement of orbitals around the central atom only. Okay, so it is not related, it is not considering the lone pair present in the central atom. It just checks how many bonds are there and orbitals how they are arranged. Okay, so we have seen different examples under this and how shapes of molecules are given based on Sedgwick-Powell theory. Okay, so this is for Sedgwick-Powell theory, but the limitations are there with Sedgwick-Powell theory. It doesn't undertake considerations of the orbitals of other species or lone pairs present in the outermost shell of central atom. Okay, so VSEPRT has developed, what is full form of this? It is valence shell electron pair repulsion theory, which is developed by Gillespie and Nyholm. According to this theory, geometry of molecule depends upon total number of bonding and non-bonding electron pairs present in the valence shell of central atom. Okay, and they arrange themselves in such a way that molecule will have minimum energy and maximum stability. Okay, everyone is trying towards stability, so just check out summary. And then we have seen different trends since it is valence shell electron pair repulsion. Okay, so different trends of repulsive interaction are there. So lone pair and lone pair repulsion between two lone pairs is greater than the lone pair bond pair than the bond pair. Okay, so bond pair में जो repulsion होता है, like bond pair is what? The electron pair which is under influence of two atoms. Okay, so bond which is formed by sharing electron between nitrogen and hydrogen. So this is the bond pair. Okay, lone pair क्या है? Lone pair is the electron pair which is under influence of only one atom. Okay, so this is lone pair. So since lone pair is under influence of only one atom, it expands in size and repels the bond pair. Okay, so lone, if two lone pairs are there in the molecule, like in water molecule, of course they will have maximum repulsion than the electron pairs of the lone pair and bond pair, and then the bond pair. So in case of water molecule, if you see with respect to methane, okay, bond angle is decreasing. Ammonia will show lower bond angle and least bond angle will be there in water molecule in these three examples. Okay, that is because of this trend of lone pair and bond pair repulsion. Okay, so remember the trends. We have seen different effects in this. Okay, so remember effect of every term, like कि lone pairs रहेगा molecule में, same example is there. You will see formula is same, NO2. One is a nitrile ion, NO2 1 plus. Another one is nitrogen dioxide radical, NO2 dot. And third one is nitrite ion, NO2 1 minus. Okay, so in all these three examples, you know, different in first example there is no lone pair. In second example, no lone pair on nitrogen, but one unshared electron is there. Okay, so because of that also the bond angle is decreased. You know, in nitrile ion 180 bond angle is there. In nitrogen dioxide radical it is drastically decreased because of this electron. Okay, and when there is lone pair, further that angle is decreased from 134 to 115. Okay, so though in all three molecules formula wise it is very same, but arrangement of electrons is different. Okay, that is beauty of VSPRT theory. Okay, so I hope you will remember all the examples. Okay, methane, ammonia, water molecule. So number of electron pairs, total number of electron pairs in all the case it is 4. Total number of electron pairs in all the case it is 4. But if you see bond pairs and lone pairs, number is variable. Okay, so in first example total bond pairs are 4. In second example bond pairs are 3 and lone pair is 1. In third example, 2 bond pairs, 2 lone pairs are there. Okay, so accordingly structure will change. Methane with regular 4 numbers of electron pair, it is regular tetrahedral. Now because of lone pair, tetrahedral geometry is changed to trigonal pyramidal, and now for water molecule it is further reduced to bent or just V-shaped molecule. Okay, so remember these effects. Then other effects also we have seen, so go through each and every effect. Effect of electronegativity. Okay, this is from one nitrogen family, how it is as we move from top to bottom. Hydrides of group 15. Okay, even we have seen hydrides of group 16. So how bond angle is decreasing. Okay, the trend you remember. Then similarly for group 16 hydrides also bond angle is decreasing, and we have seen the effect also with the multiple bond. Remember the effect. Okay, then with incomplete shell, how the bond angle is variable. Okay, so applications of VSEPRT theory include, so based on all these assumptions, now VSEPRT theory is used to check geometry of regular geometry molecules, irregular geometry molecules, and many more. So let us first see regular geometry molecules. Four criterias are there for regular geometry molecule. Okay, so molecule must obey these criteria, then only it can be categorized under regular geometry molecule. Okay, then for irregular geometry molecule also there are some criterias, so just go through criterias of this. So there can be question like identify given molecule is regular geometry or not. Okay, so remember NH3, though it looks like regular geometry, 3 are hydrogen, 1 is nitrogen, but there is lone pair. PCl5, no lone pair is there. All four chlorines are there. It obeys many properties of regular geometry, but remember, since it is trigonal bipyramidal, bond lengths are different, bond angles are different along equatorial and axial. So PCl5 is again not in regular geometry. PCl5 is irregular geometry molecule. So we have seen some of examples under that, which molecules though look very similar to regular geometry molecule, but they are not. Okay, so in application, remember the formula of steric number calculation and the table for that. Okay, just we will see final table for that. With respect to steric number calculations, remember the arrangement. Okay, what are possible uh, geometries of the molecule. Okay, so calculation of steric number, if some example is given, try to calculate its steric number. You will readily get from this table the geometry of molecule. Okay, so with respect to steric number, geometry and all thing is given here for the regular as well as irregular geometry molecules. Okay, so remember this table. Then we have seen further applications for every type of combination of the molecules. Okay, so just go through that with lone pair, without lone pair, what happens is to the molecule. Okay, so again without lone pair में you will get actual structure क्या है, predicted structure क्या था. Okay, so this is predicted structure when there is lone pair present. Okay, how tetrahedral geometry reduces to the bent V shape. Okay, in the water molecule that we have seen. So just go through all the elements present. Okay, so दोनों जितने भी tabular data है, prepare it very carefully. Examples will be asked. So in summary, just prepare all the tables. Okay, all the tables you prepare carefully. Arek E stands for lone pairs present. Okay, with the introduction of lone pair, how the regular geometry changes to actual shape of molecule. You need to write in the final shape. Okay, actual shape of molecule instead of special arrangement क्या रहेगा. Okay, so this is about the first half of the unit. Chemical bond and reactivity. Also prepare for isoelectronic principle. Now we will quickly revise oxidation and reduction process. Okay, so in oxidation and reduction, uh, remember all the definitions of oxidation and reductions with respect to different phenomenon, different concepts we have seen, right? So in classical concept, and electron transfer concept, we have seen different definitions of oxidation and reduction. Okay, oxidation का classical concept है addition of oxygen or any electronegative species, either add oxygen or similar type of electronegative species. Even if you add chlorine in this reacting molecule, that can be oxidation. Okay, or remove hydrogen or remove any electropositive species from the reaction, it can be oxidation reaction. In terms of electron transfer concept, we have seen it is loss of electron. Okay, is oxidation. When electron is lost out of system, positive charge on element, okay, basic element, जो element से electron lose हो गया है वो element का positive charge increase हुआ, then also it is oxidation. Okay, Fe2 plus converted into Fe3 plus, positive charge is increased, then that is oxidation. Okay, or if some negative species is there, then if negative charge is decreased, O2 minus is converted into O1 minus, then that is oxidation. Okay, so different concepts of oxidation and reduction are there. Similarly, you can remember concept of reduction, exactly opposite to the oxidation. Then we have seen oxidizing agent and reducing agent. ऑक्सीडाइजिंग एजेंट सामने वाले स्पीसीज का ऑक्सीडेशन करता है. ओके, सो ऑक्सीडेशन के लिए रिक्वायर्ड क्या है, ऑक्सीजन लगेगा या इलेक्ट्रोनेगेटिव एलिमेंट लगेगा ऐड करने के लिए. सो ऑक्सीडाइजिंग एजेंट प्रोवाइड्स oxygen or any electronegative species, or it helps to remove hydrogen or any electropositive species. Okay, तो ऑक्सीडाइजिंग एजेंट ये सब प्रोवाइड करता है और दूसरे एटम से हाइड्रोजन को खींच लेगा. ओके, रिमूवल ऑफ हाइड्रोजन और एनी इलेक्ट्रोपॉजिटिव स्पीसीज. तो ऑक्सीडाइजिंग एजेंट, इट इंक्रीजेस ऑक्सीडेशन नंबर ऑफ स्पीसीज, जो सामने वाला स्पीसीज है उसका ऑक्सीडेशन नंबर इंक्रीज करेगा और इट विल कैप्चर इलेक्ट्रॉन. तो व्हेन इट कैप्चर्स इलेक्ट्रॉन, ओके, सामने वाले स्पीसीज से तो इलेक्ट्रॉन लूज हो गया, ऑक्सीडाइजिंग एजेंट ने इलेक्ट्रॉन वो कैप्चर कर लिया है, तो इट सेल्फ विल अंडरगो रिडक्शन, बिकॉज रिडक्शन इज व्हाट, इट इज gain of electron. Okay, reduction is gain of electron. So remember that way all the definitions of oxidation and reduction, oxidizing agent and reducing agent. Now oxidizing agent itself undergoes reduction, reducing agent itself undergoes oxidation. So in redox reaction both the reagents are present simultaneously, therefore oxidation reduction reactions are complementary to each other. Then we have seen different rules to calculate oxidation number and simple formula like कि K2Cr2O7 का हमने देखा था. तो if क्रोमियम का ऑक्सीडेशन स्टेट डिटरमाइन करना है, सिंस क्रोमियम इज पॉजिटिव इन नेचर, तो रिमूव फर्स्ट ऑल पॉजिटिव स्पीसीज देन नेगेटिव स्पीसीज एंड जस्ट कंसिडर जो भी अननोन रहेगा उसको x कंसिडर करो. तो लाइक 2x विल बी 2 chromiums are there, 2x will be oxidation number of chromium here. Okay, so just derived it to 6. Okay, so this is how you can derive oxidation number of any species. Always remember fluorine is most electronegative species. Okay, so when fluorine is bounded to any other element, fluorine will be always considered as 1 minus. Okay, and if oxygen is bounded like OF2, OF2 species may, in case of OF2, okay, OF2, two fluorine atoms are there. Okay, two fluorine atoms are there. So here one fluorine is 1 minus. Okay, so two fluorines will be 2 minus. Okay, so what will be oxidation number of oxygen? Since molecule is neutral, so therefore oxidation number, ON, is oxidation number of oxygen in this example will be 2 plus, okay, plus 2. Remember this, oxygen when combines with fluorine, it shows plus oxidation state, okay. So remember this example also. Then in this topic we have seen different balancing of reactions, okay. So just go through all the reaction balancing. Electrochemical series हमने देखा था. Electrochemical series very important. Here many aspects were explained कि substances more strongly electronegative than hydrogen have positive redox potential, more positive potential, greater is its affinity for electron, okay, or less rahega to. So in this electrochemical series, if you just summarize together electrochemical series. Okay, you will find कि as we go up, tendency for oxidation to occur will increase, and increasing strength of reducing agent. So lithium will be strongest reducing agent, and as we go down, okay, down the electrochemical series, what you will find ki tendency of reduction to occur will be increasing here, okay. So increasing strength of oxidizing agent. So your fluorine is highest oxidizing agent, highest power of oxidation, okay. So remember the trends. And hydrogen is at middle position, having standard electrode potential 0.0 electron volts, okay. So remember the electrochemical series at the same time. Then we have seen balancing of redox reactions. So just go through rules of balancing of redox reactions. ऑक्सीडेशन हाफ, रिडक्शन हाफ कैसे आइडेंटिफाई करते हैं, ओके. सो लॉस ऑफ इलेक्ट्रॉन कौन से स्पीसीज में हुआ है, गेन ऑफ इलेक्ट्रॉन कौन से स्पीसीज में हो गया है, जस्ट चेक दैट, okay. Then remember this range of neutral water, sorry, natural water का pH range is 4 to 9, okay. Natural water का pH range is 4 to 9. Then Latimer and Frost diagram concept we have seen. Latimer diagram क्या है? Latimer diagram is the simple way of representing series of steps, stepwise half reactions connecting various oxidation. Okay, so in this case, Latimer diagram is flow sheet. Okay, Latimer diagram is flow sheet where arrows link oxidation state forming redox couple. Okay, तो arrows सिर्फ explain करते हैं हम लोग, and standard E naught values are written around the arrows. Whereas in the Frost diagram, it is graphical plot. Frost diagram is graphical plot of standard reduction potential Ne versus oxidation number. Okay, so it is plot of Ne versus oxidation number is Frost diagram. It is graph. Okay, so gives free energy versus oxidation number is calculated over here. Ne stands for Gibbs free energy versus oxidation number. प्लॉट को फ्रोस्ट डायग्राम बोलते हैं, okay. So application, this is how the Latimer diagram can be shown, and Frost diagram is graphical representation, okay. So this is one of graphical representation of Frost diagram. Gibbs free energy is shown on y-axis and oxidation number is shown on x-axis. So this kind of representation is Frost diagram, okay. So this we have seen. Then again we have seen redox titrations. particularly iodometry and iodimetry we have seen. Iodimetry क्या है? Analyte is D. Iodimetry is directly titrated with iodine. Okay, so iod D stands for directly titrated with iodine. This is direct type of titration. Determination of amount of reducing agent can be done with iodimetry. Okay, reducing agent का amount निकालने के लिए iodimetry use करते हैं. Iodometry is what? Liberated iodine. Okay, where iodine is not now directly used. Liberated iodine, तो कोई reaction mixture मिक्स किया रहता है, उससे जो आयोडीन लिबरेट हो जाएगा, दैट इज टाइट्रेटेड विद द स्टैंडर्ड सॉल्यूशन ऑफ थायोसल्फेट. ओके, सो इट इज indirect method. Okay, iodimetry is indirect method. Iodimetry is direct method. In this, iodometry is used for calculation of amount of oxidizing agent. Okay, iodo O oxidizing agent का amount निकालने के लिए करते हैं. Now remember, iodine is water insoluble, so it is always mixed with Ki solution. Okay, so in all the types of iodometric titration, you will find redox titration where iodine is used, you will find Ki is added since iodine is insoluble, and starch is used as an indicator. Okay, starch is used as an indicator. So this is all about oxidation and reduction unit. So in both the unit, prepare all the definitions very carefully. Okay, and then concepts of each point very carefully. Remember all examples. Oxidizing agent, reducing agent के examples याद में रखो. KMnO4 is strong oxidizing agent. It is self indicator also. Okay, KMnO4 is self indicator also. So remember that for KMnO4 titration you don't require any additional indicator. KMnO4 itself act as indicator. Okay, so I hope you will prepare well for this topic. Okay, all the best. Chalo, bye bye.